Okay guys, so I'm sorry this took so long to get around to, but we're on page 4 of our review. So let's look at number 1. We have 27 r to the 9th over s to the negative 9 over 3, all of that to the 2/3. So what we're going to need to do is we're going to need to distribute this 2/3 exponent to every part of the rational expression we have here. So let's go ahead and break it apart. Let's go ahead and do 27 to the 2 over 3. And remember, 2 over 3 exponent is going to be the cube root of 27, and that's going to be squared. Remember, our root is our denominator, and our exponent becomes our numerator. So the cube root of 27 is 3, and when we square that, we get 9. So the first part of our answer is going to be 9. And then let's go ahead and do r to the 9th to the 2/3, r to the 9th to the 2/3. Now, when we multiply an exponent to another, raise an exponent to another exponent, we're going to multiply the exponents. So we're going to have 9 times 2/3 as our new exponent. That becomes 18 over 3. And 18 over 3 is 6, so r to the 6th. And that's going to be our rest of our numerator. And then finally, we have s to the negative 9 over 3 raised to the 2/3. So we're going to have s to the negative 9 over 3 raised to the 2/3. And we're going to go ahead and multiply our exponents because we're raising an exponent to another exponent. Notice how I don't lose the negative yet. I'm going to keep the negative where it is just until the end. So that's going to give me s to the negative 18 over 6 because when we do multiply fractions, we multiply straight across. 18 over 6 is negative 3. So it's going to be s to the negative 3. But this is not our final form, okay? We don't like negative exponents. So in order to get a negative exponent, remember we move it to the other side of the fraction bar. And we are going to go ahead and spread that out. So 9r to the 9th, 6, s to the 3rd. All right, so that's how we do that one. Okay, so number 2 on this page is the cube root of 25 x to the 4th over 3x. Now, one thing we could do is we could simplify these x over x and the 125 over 3 to do that, and just make sure if it's a cube root. So what I like to do first is go ahead and go in my calculator, and I'm going to hit Control and then my caret button so I can get the cube root of 125, which is 5. And if I take 125 and divide it by 3, I'm going to end up with a non-whole number. So I'm going to go ahead and break this apart so that I can have the cube root of 125 separate. But I'm also going to go ahead and simplify the x to the 4th over x as well. So let's go ahead and do that. All right, so we're going to break this apart. We're going to have the cube root of 125. And then x to the 4th over x, that becomes x to the 3rd. So I'm going to go ahead and the cube root of 25x to the 3rd for my numerator. And I'm going to have the cube root of 1 over 3 as my other part. And then the cube root, we decided the cube root of 125 is 5. And the cube root of x cubed is just going to be x. And then I'm left with the cube root of 1 over 3. Okay, so you can leave it 5x cube root 1 over 3. We can have 5x over the cube root of 3. Those would also work, both of those. So you can break this apart any way you want, but we need to make sure we do break it apart. So the next one is just an equation. Shouldn't be too bad. It says the square root of 2a plus 3 minus a equals 0. So what a lot of you have been doing is squaring first, but remember, when we're solving an equation, we do our backwards order of operations, the SADMAP. So we have to undo addition and subtraction first. Exponents don't get undone all the way till down here. And a radical is the same thing as an exponent. Radicals and exponents go together. Okay, so remember, a radical is just an exponent in a fraction form. So what we're going to do is we're going to go ahead and undo the subtraction first by adding a to both sides. and that's going to give me the square root of 2a plus 3 is equal to a. Now there's no more addition, subtraction, or multiplication and division I can undo, so now I can undo this radical. And to undo the square root, I'm going to square both sides. And that's going to give me 2a plus 3 equals a squared. So I'm going to go ahead and move my a squared to the other side. So I'm going to have negative a squared plus 2a plus 3 is equal to 0. Okay? So we're going to go ahead and I'm going to do this one by completing the square because b is an even number, and that's an easy way to solve. So we have our divide by our negative, our a. So remember our a is negative 1, so we're going to divide both sides by negative 1. And we get a squared minus 2a minus 3 equals 0. And then I need to move the minus 3 over. So I'm going to add 3 to both sides. And I'm going to be with a squared minus 2a equals 3. Now then we are going to add to both sides b over 2 squared. So negative 2 over 2 quantity squared. All right? So that's going to be negative 2 over 2 is negative 1. Negative 1 squared is 1. So we're just going to add 1 to both sides. And that's going to give me a squared minus 2a plus 1 equals 4. Now it looks like I've run out of room on this one, so I'm going to go ahead and flip it to the back. One moment. Okay, so we've moved to the back of the page, so we have some room. We have 2a squared minus 2a plus 1 equals 4. So we're going to write this as a square. We're going to have a minus 1 quantity squared equals 4. And remember, the way we get this is our first term minus our, or plus b over 2. Sorry. And then we square that. So our b over 2 is negative 1, and that's why it becomes minus 1 here. So now I have a square. I'm going to go ahead and undo again. So now I'm going to undo the square. I have a minus 1 equals plus or minus 2. And I'm going to add 1 to both sides. And then I'm going to have a equals negative 1 and positive 3. However, we need to go ahead and make sure that neither of these solutions is extraneous. So what we do is we take our solutions and plug them back into the original equation, which was square root of 2a plus 3 minus a equals 0. So let's go ahead. We're going to plug in both of these numbers for a. So we're going to have 2 times negative 1 plus 3 minus negative 1 equals 0. And then that's going to give me negative 2 plus 3 plus 1 equals 0. And this is going to give me the square root of 1 plus 1 equals 0. And then square root of 1 is 1 plus 1 equals 0. And 2 does not equal 0. So it looks like negative 1 may very well be an extraneous solution. And we'll check this in the calculator. It is possible that because the square root of 1 is plus or minus 1, that we can call this a solution as well. So we'll double check the calculator and see what the calculator tells us as well. It's always a good idea to double check the calculator when possible. All right, so let's go ahead and check 3. We'll put it right here. 2 times 3 plus 3 minus 3 equals 0. So then again, we're going to go ahead and do our order of operations. We have to take care of what's inside our grouping under the radicals of grouping. So you have 6 plus 3 minus 3 equals 0. And then we have 9, square root of 9 minus 3 equals 0. Square root of 9 is 3 minus 3 equals 0. And then 3 minus 3 is 0 equals 0. So that one checks out. So our a does not equal negative 1. A equals 3. All right. Okay, so what I've done here is I've entered it into our calculator, into the graph form. This is what the equation ends up looking like. Notice it only crosses here at positive 3. So again, the only true solution to this one was positive 3. I did switch all the a's to x's because we were in our calculator, and the calculator does not understand that whatever variable will work. All right, so we did double check it. It does show that the only 0 is negative 3. So therefore, negative 1 is an extraneous solution. Okay. Okay, so moving along, we have a word problem here. Now, word problems do require a little bit more effort. We can't just take them and plug them in and go with it. We need to work them out. So we need to also pay attention to what's being used here. So this one right here, this one's a calculator question. So we're going to be able to use our calculators on the semester exam when we take this. We have t is equal to d over 16, the square root of d over 16, which is the time t in seconds for a free-falling object to fall d feet. So we have a 63 feet high and when it strikes the puddle. So previously we've had this problem where somebody dropped a coffee off the balcony and within 5 seconds it had spread all over the floor. However, we don't care about when it spread all over the floor. We only cared about when it hit the ground. So the same thing here. We don't care about what happens after it hits the ground, when it hits the puddle, okay? We don't care what happens when the nail goes under the water, just when it hits the water level. So all we're going to do is take t. T is going to be unknown. We do not know unknown because it says how long. That's our unknown. So our square root, we have our d. D equals 63. So we're going to have the square root of 63 over 16. And then this is simple. This one requires a calculator. We're just going to take it and plug it into the calculator. So let's do that. So we have the square root of 63 over, oops, sorry, it looks like I typed in squared. Square root 63 divided by 16. And it's going to give us 1.98. And it says round to the nearest tenths on our assignment right here. So tenth is going to, if we have 1.98, if we round this up to the tenth, that's going to round that to as 10. So it's going to be 2.0. The appropriate way to round this to the nearest tenth is 2.0. So t is approximately equal to 2.0 seconds. Make sure you are rounding correctly. Remember, I only have so much leeway on these exams. All right, so finally we have our complex numbers on this page. This one's pretty simple. We're just going to FOIL them on the number 1 and number 2. So negative 2 times negative 10 is negative 20. And then we have negative 2 times 3i gives me negative 6i. And then I have negative I times negative 10, and that's going to give me positive 10i. And then finally, I have negative I times positive 3i, and that's going to give me negative 3i squared. And we're not going to leave the I squared as I squared. Remember, I squared is negative 1. So we're going to rewrite this as negative 20 minus 6i plus 10i minus 3 times negative 1. Negative 3 times negative 1 is positive 3. So I have negative 20 plus 3 gives me negative 17. Negative 6i plus 10i gives me positive 4i. Now remember, we always put the I part second. It's always after the real part. The imaginary comes after the real. So let's do number 2. 2 times negative 5 is going to be negative 10. 2 times negative 3i is negative 6i. 3 times negative I times negative 5 is negative 15i. And 3i times negative 3i is negative 9i squared. Again, we're going to go ahead and rewrite. Negative 10 minus 6i minus 15i minus 9 times negative 1. And negative 9 times negative 1 is positive 9. So we have negative 10 plus 9, and that's going to give me negative 1. And negative 6 minus 15, so negative 6i minus 15i is going to give me negative 21i. And remember, these are the only cases when you're doing multiplying complex numbers. It's the only time you're going to get binomial times a binomial equals a binomial unless they have opposite signs in the middle and everything else is the same. All right. So now we have our 10 plus 3i over 2 minus I. Now we don't like having i's in the denominator. So we're going to go ahead and we're going to rewrite this as a regular division problem, make it a little easier to see. And remember, to get rid of i's in the denominator, we need to rationalize the denominator. So to rationalize the denominator, we're going to multiply by its conjugate. And remember, that's basically just change the operation. So the easy part here is doing the bottom, okay? We just do the square. 2 times 2 is 4. Negative I times positive I is negative I squared, which gives me positive 1. And that's going to mean it's going to be 5. The harder part is going to be the top times the top. But it's no different than what we just did up there. So we have 10 times 2 gives me 20. And then we have 10 times I, positive I gives me positive 10I. We have 3I times 2 gives me 6I. And 3I times positive I gives me positive 3I squared. So again, we're going to rewrite 20 plus 10I plus 6I minus 3, because remember, I squared is negative 1. 20 minus 3 is 17, and 10 plus 6 is 16I. So we're going to have 17 plus 16I, and we're going to put that over the 5, and that's our answer. Same thing over here for 2i, or 2 plus 3i. So we have 2 plus 3i over 4 minus 5i. We're going to rationalize the denominator same way by multiplying by the conjugate of the denominator. So remember, that's 4 plus 5i and 4 plus 5i. And it has to be the same thing, top and bottom, or else it won't be the same expression. We have to multiply by a form of 1. Anything divided by itself is 1. So 4 times 4 is 16. Negative 5 times positive 5i is going to be negative 25i squared. And remember, I squared is negative 1. So this is going to give us 16 plus 25. And that is going to give us 6 plus 1, 41. Okay, that's going to be our denominator. And then we're going to multiply the two binomials up top again. So 2 times 4 is 8. 2 times 5i is 10i. 3 times 4 is, 3i times 4 is 12i. And 3i times 5i is 15i squared. Again, remember, I squared is negative 1. So we're going to have 8 plus 10i plus 12i minus 15. 8 minus 15 is negative 7. 10i plus 12i is 22i. So we're going to have negative 7 plus 22i for both of these. And we can't simplify any further, so we're just going to leave it like this. Okay? All right, so that's page 4. We'll go ahead and move on to page 5 in just the next video. So go ahead, and if you have any questions, let me know, and I'll see you soon.